We have set up confidence intervals for the population mean and for the population variance. So now we're going to find a confidence interval for the population proportion. Now recall that an estimator for the population proportion, which we indicate with a P, is the sample proportion P hat, which is equal to x over n, where x is the number of successes and n is the sample size. We also know that the sampling distribution of P hat, the sample proportion, can be approximated by the normal distribution with a mean of P, that's the population proportion, and a variance of P1 minus P over n. And that is provided that n times P and n times 1 minus P are greater than 5. That is so that the approximation is a good approximation. So from this, we can get the test statistic for P so that we can use the statistic to set up our confidence interval. So the test statistic, Z, is equal to P hat, and then we standardize by subtracting P, the population proportion, and we divide by the standard error. The standard error is just the square root of the variance, so it's the square root of P1 minus P over n. And this is a good approximation when NP and N1 minus P are both greater than 5. Now from this, we can set up the confidence interval for P. Now, you will recall when we've constructed the confidence interval for the population mean mu, that we constructed the confidence interval in a similar way. And just to remind you, we can say that the probability that standard normal variable z lies between minus z alpha over 2 and positive z alpha over 2 is 1 minus alpha. And now we substitute this z with the test statistic on the previous slide. So we substitute that z with this statistic because it follows the standard normal distribution. Okay, and now we can do a little bit of algebraic manipulation just so that we get our P, our population proportion on its own. And if you do that manipulation, you will find the following. Okay, so the probability that P, the population proportion, lies between this factor and this factor is equal to 1 minus alpha, and it's from that that we set up the confidence interval that we have here on the slide. Okay, but now the problem is that we are setting up a confidence interval for P, but in this formula we have P. So how can we set up a confidence interval for P making use of P? So what we do is we just substitute our population proportion P in our confidence interval formula. We substitute our P with a P hat. And this then gives us a 1 minus alpha confidence interval for P, provided that NP hat and NP hat minus 1 is greater than 5. Okay, so let's look at an example. In an advertisement, the manufacturer of a certain toothpaste claims that 80% of dentists recommend the ingredients in this product. To test this claim, a consumer protection group randomly sampled 300 dentists and asked each one whether he or she would recommend toothpaste that contained this ingredient. Of the 300 dentists, 231 said that they would recommend toothpastes that contain the ingredient. So we want to calculate a point estimate as well as a 90% confidence interval for the true population proportion of dentists that would recommend these toothpastes. So first of all, to get a point estimate, we use the sample proportion p hat, which is x over n sample size. So my x is the number of successes, so that is 231 divided by my sample size, which is 300. So a point estimate for the true population proportion is 0.77. Now remember that a point estimate doesn't give us any indication of how good this estimate is expected to be. So therefore, we prefer to set up a confidence interval or an interval estimate. And now we just substitute all the information we have in this example into the formula for the confidence interval for P. So here you can see that I use P hat 0.77. Then I subtract Z alpha over 2. Now remember, we are setting up a 90% confidence interval. So alpha is 10%, alpha over 2 is 0.05. And by now, you should recognize this Z is 0.05, which is equal to 1.645. Okay, and then I multiply it with square root of p hat, 1 minus p hat divided by n. So p hat we already calculated as 0.77. Our sample size n is 300. We do the substitution for the lower limit as well as for the upper confidence limit, and then we get a confidence interval of 0.73 for the lower limit and 0.81 for the upper limit. Okay, and therefore we can say that this claim of the manufacturer seems to be reasonable because 80%, 0.8, lies within this confidence interval. Now, similar to when we find an interval estimate for the population mean, we can also control the interval width when we estimate P by determining the sample size. So remember, we would like our confidence interval to be as narrow as possible, but still have confidence in our confidence interval. And we can control that by selecting a certain sample size. Okay, so let's look at an example. In a brand preference survey, we want to estimate the proportion of customers who prefer our company's brand. And we want the error of estimation, so that is the difference between the population proportion and the sample proportion, to be no more than 3% with 95% confidence. So we can rewrite the above information in the following way. We can say that the probability that the absolute error, so the error is the difference between the sample proportion and the population proportion, the probability that the absolute error is less than 0.03 is 0.95. Or we can also write it as the probability that the difference between p hat and P lies between negative 0.03 and positive 0.03 is 0.95. Now you will probably recognize this process from when we determine the sample size if we want to set up a confidence interval for the population mean. We will next divide by the standard error throughout. Now the standard error for the sampling distribution of p hat is the square root p1 minus p over n. So now we divide with the standard error throughout, and you will recognize that this statistic here follows the standard normal distribution. So now I substitute my statistic with Z, which is a standard normal variable, and the probability that Z lies between this lower limit and upper limit is 0.95. And you will remember that Z 0.025 is equal to 1.96. So therefore we can set 0.03 divided by P1 minus P over N. We can set that equal to 1.96. And then we solve for N. Okay, so there remains one last thing, and that is that we have to substitute P. So with what are we going to substitute P? Because we are determining the sample size so that we can estimate P. So we don't have P at this stage. Now there are two common methods to find a value for P. The first one is to take a preliminary sample and then to calculate the sample proportion and use that sample proportion and substitute it into the formula. Or if you don't have any idea of what P should be, then an upper bound can be found by substituting P with 0.5. The reason for that is that if we substitute P with 0.5, then P1 minus P will be at its maximum, and that will be 0.25. For any other value of P, this product will be less than 0.25. So this will give us an upper bound for N, the sample size. Okay, so we will use the second method here, and that is to substitute my P with 0.5. So if I substitute my P with 0.5 in my formula, then if you do the calculations, you will get 1067.11. But remember, because we are finding a value for N for the sample size, we always round up. So we will work with a sample size of 1068. Okay, to summarize this in general, to estimate the population proportion with the level of confidence at 1 minus alpha, so that the error of estimation is less than a factor E, the sample size required is equal to P1 minus P times the square of Z alpha over 2 divided by E.